13. Write the system of equations needed to model this situation. The results of a recent high school swim meet stated that 30 individuals placed, earning a combined total of 67 points. First place earned 3 points, second place earned 2 points, and third place earned 1 point. There were as many first place finishers as second and third place finishers combined. So our variables this time would need to represent the number of finishers. So F is going to be for first place finishers, or number of first place. S will be the number of second place. And T will be the number of third place. So it said that there was 30 individuals. So that means the first equation should be first place plus second place plus third place equals 30. It also said that to get first place you get 3 points, second is 2, third is 1, and a total of points was 67. So that means 3F plus 2S plus 1T is equal to 67. Then it goes to say there were as many first place finishers as second and third place combined. Combined means to add. So first place was equal to the combination of second and third. So this is the system of equations for this scenario. It doesn't say solve it, but so we're going to leave it as is. If it did say solve, you would have to take the third equation and put it in standard form by canceling out S and T on that side and bringing it over to the other side. So you would have had F minus S minus T equals 0 if it said solve. But since it doesn't say solve, we're going to stop at the equations that we wrote in red. Just keep that in mind. You never know what could come up on the test. But if you're solving a system and you're using matrices, you must put all variables on one side. And all those variables have to be on the left side. I repeat, you move all variables to the left side if you want to use matrices. If you're using another method, then fine. Leave everything where you want it to leave it. "14. Find the domain and range for each graph." So on the graph on the left, the lowest x value is right here at -9, and there's a closed dot. So I would put a solid line to represent -9. The highest x value is 8, but there's an open dot, so I'm going to make a dashed line at 8. So that's the frame for my graph. So my domain is from -infinity to 8. If I write it in interval notation, or in inequality notation, I would say -9 less than or equal to x less than 8. Okay, now let's talk about the range. Range is your y values. Start from the bottom, work your way up. On the bottom of the graph, there's an open dot, so it's going to be a dashed frame, and it's at -2. The highest y value is 7. and it's a closed dot, so it's a solid frame. So the range is -2 to 7. Always put the smallest number first. On -2, I'm going to put a parentheses, but on 7, I'm going to put a square bracket. They kind of look the same. Let's make it a little more curved. So that's if I'm writing it in interval notation. If I'm writing it in inequality notation, I would put -2 less than y less than or equal to 7. So always write your domain from least, or your range from least to greatest, smallest to largest. Always. Even if you're listing out numbers, always put them in order. On the graph on the right, the domain, again, is your x's. So over here on the far left, that graph has an arrow. So that means it's continually going to the left. So that's negative infinity. You can't build a wall. If I trace the graph all the way to the far right, again, there's an arrow. So it's constantly going to keep moving to positive infinity. So it's non-stopping. So we would say the domain is negative infinity to positive infinity. In interval notation, in inequality notation, you would say negative infinity less than x less than infinity. Or in words, this would say all or any real number. I'm just preparing you for anything you might see. Okay? All right. Now let's talk about the range. Range is always your y. Start at the lowest of the low. So down here, again, there's arrows. So that's a negative infinity. But when I trace the graph to the top, the highest point it goes, there's a dot that stops the graph from keep continuing to go up. So we can build a frame there. The y value is 5. Again, range is y. So the range on this graph in interval notation is negative infinity to 5, and we would put a square bracket on 5 since it's a closed dot. It's a definite point. In inequality notation, you would write negative infinity less than y less than or equal to 5. Sometimes they could just say y is less than or equal to 5. So that covers everything less than 5. Um, and that's usually one of the few, those are the ways you would normally see the domain and range written for these particular graphs. Yes, there is set notation as well, but set notation is just using the fancy braces. If it's domain, you put x and then your bar. So x such that, and then what comes after the bar usually is an inequality or words. So for example, in this one, I would put negative infinity less than x less than infinity, or I could have put it in words and said x such that x bar any real number. For my range, it would be y such that, and again, I would usually have the inequality less than y less than or equal to 5, or they could just simply put y bar such that y is less than or equal to 5. So the set notation, what comes after the bar, is totally up to the person who's writing the answer. There's no only one way to write it. There is a right way, but there's not only one right way. 15 says state whether 5, negative 6 is a solution to each of the inequalities. So that means we're going to let x be 5 and y be 6 and substitute those values in their places. So bring everything else down but x and y. So y is negative 6 and x is 5. So carry down the negative 6. 2 times 5 is 10. Carry down the negative 6. 10 minus 12 is negative 2. This statement says negative 6 is less than negative 2. That is true. So yes, 5, negative 6 is a solution to the one on the left. Now we're going to see if it's a solution to the one on the right. So bring everything else down. Again, we're replacing y and x. Y is negative 6. X was 5. Carry down the negative 6. 5 minus 8 is negative 3. Carry down the negative 6. The absolute value of negative 3 is positive 3, so that ends up being 2 times 3. And the calculator can do all of this. Yes, it can, but let's say you don't enter something properly or forget how to do absolute values. This is how you should show your work. 2 times 3 is 6. And 6 minus 4 is 2. So this statement would say negative 6 is greater than or equal to 2. That is false. So, no, 5, negative 6 is not a solution to the graph or the inequality on the right. 16. The following table shows the relationship between the number of hours practiced and number of free throws made for 5 players. Find the prediction equation. So this is when we used our linear regression. And the hours practiced is X, and we're going to put that in list 1. The free throws made was Y, and we're going to put it in list 2. So let's grab our calculator. Let's clear our list by hitting stat 4 for clear list, second 1 for list 1, comma, second 2 for list 2. Hit enter. We're done. Now go to stat, edit, so we can enter our list values. So 4, I'm sorry, 1, 4, 7, 10, and 12. Go in list 1. In list 2, put 3, 12, 20, 26, and 30. Make sure you entered all the data from the table properly. And now we go to Stat, Calc, then Regression. Go down to Calculate because everything is where we want it to be. Hit Enter. So A is approximately 2.44 rounded to the second place. B is approximately 1.61 rounded to the second place. So to write the equation, it would be y equals 2.44x plus 1.61. Alrighty, 17 is similar to 16. So let's get our calculators back. Let's clear our data. So stat for clear list, second 1, comma, second 2. Our lists are clear. Now go to stat, edit. So in list 1, we're putting 1, 3, 4, 7, 12. List 2 is 2, 5, 7, 19, 27. Everything is entered properly. Good. Hit enter. Well, no, I'm sorry. Go to stat, since it wants the prediction equation again. Stat, calc, Lin regression. Go down to calculate, hit enter. So A this time is approximately 2.43. B is approximately negative 1.13. So when you write the equation, that would be y equals 2.43x minus 1.13. 18 says the following table shows the number of scooters sold by a certain company each year. If X represents the year, find the equation for the line of best fit and use it to predict the missing value. Okay. So on this particular case, you can put years. Your scale for your years could be 2010, exactly as it appears, or you can change your scale and say that the first year was 0 and so on and so forth. Typically, we start with 0 and then work up. So let's do what is traditionally done. So what I'm saying is this year is going to be 0. 2010 is going to be 0. So that means 2011 is 1. 2012 is 2. 2013 is 3 because it increased 1 year each time. I'm not going to, 2015 would be 5 later, but I'm not going to enter that information in my list just yet because I don't have its number of scooters. So let's clear my list. So stat, clear list, second 1, second 2. Done. Now go to stat, edit. So in list 1, we're putting the years. So the first year is 0. Second one is 1, then 2, then 3. So the second list, we're doing our scooters. So 22,500 is the first one. 21,500 is the second. 2,600 is the third. And then 2,250 is the fourth value. Again, I did not use 5 in my list 1 because I don't have a y value that goes with it, and I can't run my equation, my regression, with when the values in the columns don't have the same number in each column. So I have 4 x's and 4 y's. If I put 5 in there, I would have 5 x's and 4 y's. That it won't work that way. So keep that in mind. Now let's run our regression to get our equation. So stat calc linreg. This time I want to store my equation because I need to use it. So if you know that you're going to need to use your equation, you should probably store it. So I would hit alpha trace 1. I want to store my equation and name it y1. Now hit calculate. So a is equal to negative 765 and b is equal to 22,360. So when I write the equation, it would say y is equal to negative 765x plus 2230 or 22,360. Now to find the missing information, you could type in your calculator negative 765 times 5 plus 22,360, and it'll give you an answer. Or you could hit alpha trace 1 to call the equation, parentheses 5. So you're telling the calculator, I want to use y1 equation, and I want you to substitute x with 5, and then hit enter. And the calculator does all the typing for you in the calculations. So the answer would be 18,535. So that would be the number of scooters sold in 2015 based off of this information. So the number of scooters is decreasing as the years are increasing. FYI. Alrighty. Using the correct mathematical vocabulary, describe the transformations involved for a function f of x equals x squared to turn into g of x equals negative 2 x plus 3 squared minus 9. So, when you read the equation, you read it from left to right. So the first thing I notice when I look at the new equation is this negative sign. So that negative out in front tells me that the graph will reflect the x-axis. All right, the next thing I noticed was this 2 out in front. So that 2 in front means that there's a vertical stretch. Oops, that's stretch, not streb. By 2. A vertical stretch by 2. The next thing I notice is a plus 3 inside the parentheses. When you have a plus 3 in parentheses, you do the opposite, which means you're supposed to minus 3. So that would cause the graph to shift left 3 units. And then the last thing I notice is the minus 9. The minus 9 is outside the parentheses. do exactly what it says. So the graph will shift down 9 units. All right, number 20 says sketch each of the following. Which one does not touch the x-axis? So let's get our calculator to make these graphs. Go to y equals. Clear out any information that is present. So I'm going to do -3 absolute value of x plus 1, then plus 5. Okay, and then go to y2, put 2 absolute value, x minus 4 minus 3. And then for y3, it's -4 absolute value, x minus 5 minus 7. Now I've already entered the graphs, but I only want to graph them one at a time. It makes it a little easier. So I'm going to turn off y2 and y3 so I can focus on y1 first. So there's the first graph. To sketch it, let's get some points from the table. So we need that high point, the vertex point. So the vertex was -1, 5. So it was over here at -1, 5. Then let's use 0, 2, which would be here, and -2, 2, which was right here. So -2, 2, -1, 5, and 0, 2. All right. Now I want to only look at, well, let me turn off y1, turn on y2, and graph it. So the vertex is at 4 and looks like -2 or -3. So let's look at the table so we can figure that out. So 4, what's the x value? It was 4, -3. Stop. All right. So 4, -3 was here. We can use 2, 1, which is here, and 6, 1, which is here. So again, those points were 2, 1, 4, -3, and 6, 1. And that's the reason I only want to do one graph at a time, is so that this table is a little easier to interpret. So now I'm going to turn off y2 and turn on y3. Graph it. Well, to answer the question, which one doesn't touch the x-axis, that's the third one. but we still need to sketch it. So it appears that the vertex is at 5 and negative 5 or 6. So let's look at the table. So that was negative 7, 5, negative 7. So 5, negative 7 was about here. And a point on the other side is 6, negative 11, and 4, negative 11. So let's graph them. So the vertex was 5, negative 7. The other point was 6, negative 11, and 4, negative 11. So this one does not touch the x-axis. And this concludes your review. Good luck on your DCA.